Hey guys, Mr. Betts here. Let's take a look at a couple examples that use average values in the problem, but we're going to have to apply a few different things to get our final answers here. So we are given a function f of x as a piecewise function where f of x is equal to g of x for values of x less than 2, and it's equal to just a constant 3 for values greater than or equal to 2. We know the average value of g on the interval from -1 to 2 is -5. We want to find the value of this right here. So notice that we're not actually finding an average value, but we are going to need the fact that we know the average value of g on an interval to help us with this. So the first thing I'm going to do is I'm going to start with this integral right here, and I'm going to start evaluating what I can with that, and then we'll use the other information that we're given as we need it. So the integral from -1 to 6 of f of x over 3 with respect to x, I'm going to do two things here. So that 3 in the denominator, that's just a constant that can go out front. That's the constant multiple rule, so I'm going to put the 1/3 out front. The other thing I'm going to do is I'm going to split f of x into g of x and 3 for those intervals. So I'm going to have 1/3 times the integral from -1 to 2. And then for this part, that's going to be g of x with respect to x plus 1/3 times the integral from 2 to 6 of 3 with respect to x. Okay, so to evaluate this first part right here, to get this definite integral, here's where we're going to need to use the fact that we know the average value of g from -1 to 2. So I'm going to write out what that looks like in formula notation and see how that helps us. So the average value of g of x is going to equal, this is from -1 to 2, so it's going to be 1 over b minus a times the integral from -1 to 2 of g of x dx is equal to -5. Okay, so this is the formula for average value, and then this is the actual average value that's given to us in the problem. So using this, we can figure out then that the integral from -1 to 2 of g of x is equal to 1 over 3. So 3 times -5, which would be -15. So I just multiplied the 3 here by the -5 here, and so that gives us kind of a formula or the value of the definite integral there. So this is going to equal 1/3 times -15, because that's the value of that integral right there, plus 1/3. Now we can evaluate this using an antiderivative and using that integral evaluation version of the fundamental theorem of calculus. However, if you think about what this integral here represents, we have a function that's a horizontal line from 2 to 6 with a height of 3, and we're looking for this area. Really what we just want is the area of that rectangle. So I'm going to do it that way. The width of that interval is 4, 6 minus 2. The height of the rectangle is 3, so the area is going to be 4 times 3, which is 12. So at this point, we have a numerical answer. We could just box it. I'm going to go ahead and simplify because this is a nice, easy one. And we get -1 for the value of that integral. In the second problem here, we know the average value of h on some interval. We want to know the average value of f on the same interval. So what I'm going to do is I'm going to start again with the average value formula for what we're trying to find. So the average value of f is going to equal 1 over b minus a times the integral from a to b of f of x with respect to x. And I'm actually going to go ahead and put the x times h of x squared in here like that. So this right here is f of x. Now, to evaluate this definite integral, it may not immediately be obvious, but we can use substitution here. So if we say u equals x squared, then du is going to equal 2x dx. And so this x right here is going to take care of that x right there when we make our substitution. So just to help with the substitution, I'm going to say dx equals du over 2x. And so this is going to equal 1/3. And then to evaluate this integral here, I'm going to make that substitution. So I'm going to keep the x in here for now. Then we're going to have h of u. Dx becomes du over 2x. Remember, when the dx becomes a du, now our limits need to be u values instead of x values. So when x is 1, plug into this formula right here, we're going to get u is 1. When x is 4, u is going to be 16. And x's are going to cancel. So just cleaning that up a little bit, we're going to have, I'm going to take that 1/2 out. So we have 1/6 times the integral from 1 to 16 of h of u du. So what we need to know now, and we have information in this problem that's going to help us, but we need to know what that integral is. And we are told in the problem that the average value of h of x from 1 to 4 is 2. So that tells us that 1 over 4 minus 1 times the integral from 1 to 4 of h of x dx is equal to 2. So 4 minus 1 is 3. That means the integral from 1 to 4 of h of x dx is 6. Now, notice that we have x's here and we have u's here, but it's the same integral. The only problem is that this is not the integral that we're looking for. This is the integral from 1 to 4, and we need the integral from 1 to 16. So to get that, we're also going to need to know or use this part right here. So I'm going to erase a little bit here to give myself a little room. So using that, we can say that 1 over 16 minus 4 times the integral from 4 to 16 of h of x dx is equal to 4. So 16 minus 4 is 12. So the integral from 4 to 16 of h of x dx is equal to 48. So what that means is the integral from 1 to 16, which is this integral plus this integral, that whole thing is going to be 54. So this is going to equal 1/6 times 54, which is 9.